Welcome to Lecture 1, Introduction to Java. Today, we'll take our first steps into the world of programming, exploring how Java works and why it is such a powerful and widely used language. Whether you're new to coding or have some experience, this lecture will lay the foundation for your journey in Java programming. Before we dive into Java, let's understand what a computer program is. A computer program is simply a set of instructions written by humans to direct computers to perform specific tasks, whether that's multiplying numbers, playing music, or running an entire operating system. Programs are written using programming languages such as C, C++, Java, Python. These languages act as a bridge between a human logic and machine execution, allowing us to create software that performs complex operations. One of the best ways to understand programming is through a recipe analogy. Think about how a chef follows a recipe to prepare a dish. The chef writes down a set of instructions in the recipe. The recipe requires specific ingredients. The chef follows the steps in order to prepare the dish. The outcome may vary depending on the ingredients used and the cook's skills. Now let's apply this to programming. A programmer writes a set of instructions called a program. The program requires specific inputs, and the computer follows the instructions step by step. The output depends on the inputs and the programmer's logic. Just like recipes, well-written programs produce consistent and desired results. Computers do not understand human language like English or even Java directly. Instead, they understand machine code, which consists of binary instructions. To bridge this gap, we use a compiler, a special program that translates human-written code such as Java or C++ into machine-readable code. Without compilation, the computer will not be able to execute the instructions in a program. Every computer program follows the same fundamental process. There is an input, which is data that's provided either in a form of users inputting data through the keyboard or any other input device from files or other programs. Execution. The program processes the input by following predefined instructions. And then the output. The results are displayed in various forms such as numbers, texts, graphics, or even sound. Understanding the basic flow will help you design effective programs. A challenge in programming is that different operating systems, such as Windows, Mac OS, or Linux, require different machine code. For most programming languages, this means the same program must be compiled separately for each OS using different compilers. For example, a C++ program compiled for Windows won't run on a Mac unless it is recompiled specifically for Mac OS. Unlike many languages, Java uses a unique approach. Instead of compiling directly into machine code, Java compiles into an intermediate form called bytecode. This bytecode is then executed by a Java interpreter, JVM or Java Virtual Machine, which translates it into machine code at runtime. This means that Java programs can run on any operating system as long as the Java interpreter is installed, making Java platform independent. Java has several advantages. It's platform independent. Write once, run everywhere. No need to recompile for different operating systems. Standardized libraries. Built-in tools for networking, graphics, and more simplified development. However, Java has also some disadvantages. Running Java programs is slower than compiled machine code because the Java interpreter, it translates bytecode at runtime. The other is the Java interpreter must be installed for Java programs to run. Now let's write and run our first Java program. Open any text editor and type the following code directly as written on the slide. This simple program prints hello world to the screen, an essential first step in learning any programming language. Now let's compile and run our first program. Open the command prompt or a terminal on Mac OS. Navigate to your Java directory by typing cd your path, in this example C Java. Compile the Java program using javac space helloworld.java. You should use the extension .java when you compile. This generates a compiled file named helloworld.class. Run the program with Java hello world. If everything is correct, you'll see hello world printed on the screen. Congratulations, you've successfully written, compiled, and executed your first. Java is an object-oriented programming language. OOP is a paradigm that structures programs around objects rather than procedures. In this lecture, we will introduce the basic principles of OOP. We won't use them immediately, but they will become important in the coming weeks. OOP organizes programs into objects. Each object belongs to a class, which defines its properties, the data part, and behaviors, the function part. Objects interact with one another by sending messages. This is the core idea of OOP. An object is a bundle of data and methods that operate on the data. For example, consider a dog. It has a state, which is attributes, name of the dog, color of the dog, breed, hunger level. And it has behavior, methods, barking, running, wagging its tail. Objects in programming function the same way. They have attributes and they have behaviors. Let's see real-world examples. Dog attributes name, color, breed. Behaviors bark, run, walk. Tail. Another example, car attributes color, model, speed. Behaviors accelerate, turn, change gears. Objects make programs modular and reusable. A class is like a blueprint for objects. For example, dog is a class, while individual dogs, by their name, let's call them Rex, Bella, are objects of that class. Even though all dogs have 4 legs and can bark, but each dog is unique in its own way. Objects communicate by sending messages. For example, if you whistle at your dog, you're sending a message telling it to fetch a ball. In OOP, we define classes, which are blueprints of the objects. We create objects based on these classes, and objects interact by sending messages to each other. Very soon we will be writing your own Java classes and objects.